Hello, my dear students. This is Bharat here, a math teacher who believes the most scoring subject for the boards as well as entrance is math, provided you have the positive mindset and a great strategy to execute it. So, as discussed in the previous session, we will continue with our journey of integration by partial fraction. Last session, we have solved some very important 8 questions for partial fraction. In this session, I'll be solving only 3 questions. These 3 questions are little tricky in the nature, but they are very frequently asked in the exam. These questions are tricky because at times in the exam, students don't realize very quickly that these questions are coming from integration by partial fraction. So let's start and learn these 3 questions. I hope everybody is ready with the notebook and pen. Let's begin. So question number 1 is integration of x by 1 plus x square plus x cube. When you see this question, will you be able to think about partial fraction? No, right? But right now, you know this is question from partial fraction, right? So what you can do here? The thing is, partial fraction method, you think like this, that either we have linear factors or linear repeating or one linear and one quadratic. Can you make one of this form out of this question? Okay, linear repeating or one linear, one quadratic. Now you can think, you can take that, you can hit that pause button and you can think a little bit. क्या कर सकते हैं यहाँ पे? And I'm telling you, better you take a pause here and think yourself first. If you can think of such step, I'm telling you, you are developing a right skill to learn maths. Okay? So start करते हैं. I think some of you must have thought that from x square and x cube, if I take x square common, we can do something, right? Because then what is left in the bracket is 1 plus x. Numerator x I am keeping as it is, this 1 plus x as it is. So if you observe, now we have 1 plus x. So I am just going to write 1 into 1 plus x. So I can take 1 plus x common now, right? So if I take 1 plus x common, what exactly I get? I get 1 plus x and my second bracket is now 1 plus x square, right? So we are moving in the right direction. Now this is looking like partial fraction, right? One linear, one quadratic. Up to here what we did is the most trickiest part of the problem. Now once you realize this is a proper partial fraction method, you know how to begin with one linear, one quadratic, right? We have done this kind of thing in the previous video. If you not watch that, go watch it, and if you don't remember, then also better you watch it. Okay. So what we do here is, I say, put x 1 plus x upon 1 plus x square as a upon linear part, that is 1 plus x, bx plus c upon quadratic, which is 1 plus x square. Now cross multiply, simplify, we cancel denominator from both sides. I am just skipping one of the steps, so this will be x a times 1 plus x square bx plus c times 1 plus x. Now both side denominator will be same, right? So I am not writing it. You can write it down in the exam, board exam wo likhna zaruri hoga, cancel it out and then you can proceed. Now this is a question, a small part of the bigger question where I want to find the value of a, b and c. Now there are various methods, every teacher might have their own different method. So my method is first find value of a, then find the value of c, always one linear, one quadratic. After finding the value of a, I always find value of c by putting x equal to 0. This is method which I follow. So first step is finding the value of a, right? So what we do here is, for a, I can say that I am going to put x ka value minus 1. If I put x ka value minus 1, what we get is 1 minus 1 will be 0. So this entire second part is 0, right? So I am going to do this. So the left hand side also, you don't forget, put x ka value minus 1 over there also. So minus 1, a times 1 plus minus 1 ka square, which is 1, plus this entire thing, remaining thing will be 0. So you get minus 1 equal to a times 2. So value of a you get as minus 1 by 2. Thus I found the value of a. Now let's find value of b also here, but value of b afterwards, right? First we find value of c. How we'll find value of c? So what I do here is, for c, as I have discussed, I always put x ka value 0. By putting x ka value 0, what exactly happen is, b into 0 here will give me 0. So b is eliminated, a ka value already know, so you can easily find the value of c. You can try it out yourself first. So by putting x equal to 0, so left hand side will be 0. We have a 1 plus 0, okay, b times 0 plus c and 1 plus 0, which is 1. So we just simplify this little bit. This is a and this will be c. So what I get here is, I get c as minus a. I'm taking a on the other side, so c will be minus a. But a is minus half, so this will be, what I get here is minus of minus half. I get here minus of minus half. Minus of minus half is half. So I got a ka value and I got c ka value. We want to find now value of b. So how we'll find value of b? So what I say is, for b, I can take any small value. Which small value will take? See, already I have used minus 1 and 0. So the small value which is left is 1, right? So I am saying for b, put x ka value 1. Let's check what we are getting. Okay? So if I put x ka value 1, observe what exactly I am getting here. By putting x ka value 1, left hand side will be 1. So a into 1 plus 1 ka square is 1. Plus b into 1 is b. So b into c, and 1 plus 1 will give me 2 here. So I get 2a plus 2b plus 2c equal to 1. Let's substitute the value of a, which is minus half, value of c, which is half. So this is minus 1 plus 2b plus 1 plus 1 minus 1 getting cancelled. Left hand side is 1, right? So you get 1 equal to 2b, and finally you get b ka value also half. So we got b ka value half, value of c is half, and value of a is minus half. We got all the three values. Okay. Now I am going to integrate this further. Observe इसको integrate कैसे करेंगे. This is my question here. So I am going to write now, at the place of x, I will be writing this, and I will substitute the value of a, b and c. Observe how we will do all these things. So my question, which was integration of x by 1 plus x square, which we calculated as a by 1 plus x plus bx plus c upon 1 plus x square, and we have found the values, right? What are the values? Value of c and b is half, value of a is minus half. So I just write value of a as minus half, value of b is half, value of c is half upon 1 plus x square dx. So if you observe, my question is now very simple. What I do here is, I want to integrate minus half being constant, we keep it outside, 1 plus x dx, take it separately. Half I take separately from the second part also, so we get x plus 1 upon 1 plus x square. Now this is, second part here is linear upon quadratic, right? You need to understand this questions very nicely, how to solve questions of linear by quadratic. So what I am doing here is, I keep this as it is. Right now I will integrate everything together. So linear, what is linear upon quadratic? Derivative of denominator we try to make present in the numerator, right? So what is derivative of 1 plus x square? 2x. Okay. So first thing I am doing is, I am just taking x by 1 plus x square separately and 1 by 1 plus x square separately. So you realize that even the last part, 1 by 1 plus x square, can be solved easily, because वहाँ पे integration of 1 by 1 plus x square, which is tan inverse of x. So what to do with x by 1 plus x square? This half is multiplied to both of them. So what I am doing here is, I say keep this part still as it is, this half as it is, and I am multiplying, dividing by 2 in this part. So this will be integration of 2x by 1 plus x square dx, this part separately. This part also I am going to take it separately now, and this half is multiplied to entire bracket. So I think now we can integrate all the three parts, right? The first part minus half as it is, log mod 1 plus x, plus half as it is, this half, derivative of denominator present in the numerator. So we get log mod 1 plus x square, that's okay, plus integration of 1 by 1 plus x square, which is nothing but tan inverse of x plus c. Now if you want, you can multiply this half inside. So what you get, this part will be as it is, this will be 1 by 4 log mod 1 plus x square plus half tan inverse of x plus c. Easy question, provided that first step you manage nicely. 1 plus x square plus x cube, from the third and fourth part x square x cube में से हमने x square common लिया and we made it a linear into quadratic type of question. 1 by linear into quadratic, first step is a by linear plus bx plus c by quadratic. Remember this method. Okay. So this is our first question, first little tricky question. Let's move to the second question also. My second question is more interesting. Question number 2, we have trigonometry involved in partial fraction. So if we just observe the question, what we have is, we have sin x, cos square x. So I think most of the students must have realized that at either we will be putting sin x as t or we will put cos x as t. We can do one of this thing, right? But if you observe, we can very easily take cos x dx as dt, provided if we put sin x as t. So if I put sin x as t, cos x dx will be dt. But then the question comes in the mind that what to do with cos square x. But cos square x can also be converted very easily to sin square x, right? Kaise? Cos square x can be written as 1 minus sin square x. So that's my first step. I am just converting cos square x to 1 minus sin square x. Observe what I am doing. I am keeping everything else as it is. So just cos square x I am writing as 1 minus sin square x. Everything else as it is, I am not writing it. Those part as it is. Now if you open this bracket, you get minus 1 and plus sin square x. I hope you don't make any plus minus mistake in the exam. So this part is 5 minus 4 sin x. The numerator we have is 3 sin x minus 2 multiplied with cos x and dx. What next? Can you think what is the next step? Observe. First of all, make it look like a proper quadratic equation. So I write sin square x as it is. Okay, this 5 minus 1 will be 4. I am writing it here. Minus 4 sin x. We get 3 sin x minus 2 multiplied with cos x dx. Now we can do what I was saying in the beginning, right? I'll say put sin x as t. What is derivative of sin x? Cos x. What is derivative of t? dt by dx with respect to x kar rahe hain. dx on other side. So this entire cos x and dx will be dt. So my question is now, this entire thing I am writing here as dt. Okay, this entire thing is just dt. So your question is 3t minus 2 upon t square minus 4t plus 2. But now observe closely, denominator t square minus 4t plus 2 is nothing but t minus 2 the whole square. This moment you should realize that this question is partial fraction with linear repeating factors in the denominator. How to proceed? We have done this type of question previously. So I say let 3t minus 2 by t minus 2 the whole square as a upon t minus 2 plus b upon t minus 2 the whole square. What next? थोड़ा क्रॉस मल्टीप्लाई सिंप्लीफाई करना है. As always, get rid of denominator from both sides. So if I multiply here with t minus 2, denominator will be t minus 2 the whole square. There also b, this is 3t minus 2. I have cancelled the denominator. I am not writing that step. You can do it. Now we want to find the value of a and b, right? So what I say here is, for a, can I put, let's find b first actually here also. ठीक है. So instead of finding A, we'll find B. For B, put t का value 2, because if I put value of t equal to 2, observe this t minus 2 will be 0, and we can very easily find the value of B. So don't forget left hand side. So this is we have 3 and I'm putting value of t as 2 minus 2. This will be a times 2 minus 2 वो 0 हो गया. So 6 minus 2 we get 4, 0 plus b we get b. So we got b का value, right? Now let's find value of a. So what I do here is ऐसे for a we have used value of t as 2. Now let's use some small value, right? Smallest value is 0. So we say put t equal to 0. If I put t equal to 0, left hand side will be 3 into 0 minus 2. 0 minus 2 will be minus 2 plus b. So this is minus 2 minus 2a. Let's substitute the value of b here. B ka value is 4. So on the other side we get minus 2 minus 4 will give me minus 6 equal to minus 2a. So a is minus 6 upon minus 2, which I am writing directly as 3. Okay, so I got a and b ka value. Once we get the value of a and b, integration is very easy, right? Because we have here a by t minus 2 plus b by t minus 2 the whole square, and this is what we need to integrate, right? So let's integrate this further. What I am saying is, let's integrate a upon t minus 2 plus b upon t minus 2 the whole square, and we know value of a and b both, right? What is value of a? Value of a is 3 and value of b is 4. Let me write it again. Separate कर देते हैं इनको. So 3 goes outside integration sign, 1 by t minus 2 dt plus 4 goes outside integration sign, and t minus 2 the whole square in the numerator I am taking the numerator. So it will be t minus 2 to the power minus 2 dt. Now we can integrate both of them very easily, right? The first part we get log of t minus 2. Second part t minus 2 to the power minus 1 upon minus 1. ठीक है? Minus 2 plus 1 upon minus 2 plus 1 plus c. So we just simplify. This is as it is. What I am doing here is this minus 1 and this plus 4 will make it minus 4. And this in the denominator t minus 2 plus c. One last step, put the value of t again. What is the value of t? We have taken t as sin x. So log of sin x minus 2 minus 4 upon sin x minus 2. This was in the bracket, so it can be written in the denominator plus c. That's my answer. Very simple question. ठीक है? Provided you have done this previous few steps very nicely, the way we have begun, ठीक है, was more important. Writing cos square x as 1 minus sin square x, ठीक है, getting it a proper quadratic equation in the denominator, and then putting sin x equal to t. So the beginning is more difficult. Once you realize this is partial fraction, finding a and b for repeating roots is not difficult. So ahead this question becomes very easy, provided you don't make any mistake in realizing that this question is from partial fraction. That was question number 2. Question 3 is the most interesting one. We have integration of 1 by sin x plus sin 2x. Tell me what to do here. What we can do here? 1 by sin x plus sin 2x. Think, यहाँ पे this doesn't give idea about partial fraction, right? But this is partial fraction. What to do? At least I think सब इतना तो सोच ही पाएंगे कि sin 2x के बदले 2 sin x cos x लिख सकते हैं, right? Basic trigonometry है, which I think at least everybody should clear. चलो इतना करते हैं पहले कि I'm just writing sin 2x as 2 sin x cos x. What next? At least mathematical ability इतना बोलता है कि भाई कहीं के भी कुछ कॉमन लेने पे कुछ आगे सॉल्व कर सकते हैं. तो sin x कॉमन लेके देखते हैं. चलो, so if I take sin x common, what I get 1 by sin x. Inside the bracket we get 1 plus 2 cos x. What next? Now your question is, you should focus only on this much कि भाई आपको integration of 1 by sin x in bracket 1 plus 2 cos x solve करना है. There is possibility that question can start from here also. What next? And I'm telling you the next step is the most interesting one. I'm just multiplying and dividing by sin x, and suddenly we'll make it a partial fraction. Observe. So this is sin x, and then since I'm multiplying and dividing, so denominator I'll get now sin square x in bracket 1 plus 2 cos x. Now what we can do with the sin square x? Can I write sin square x as 1 minus cos square x? So now you must have realized that if then we take cos x as t, sin x and dx can be dt. Observe what I am doing further. So in the denominator now I am writing, instead of sin square x, I am writing 1 minus cos square x. Remaining everything as it is. So this 1 plus 2 cos x as it is, this sin x and this dx everything as it is. But 1 minus cos square x, can you be write here 1 minus cos x 1 plus cos x? Now you realize that this is proper partial fraction. By just taking cos x as t, sin x dx will be minus dt. Up to here problem is very difficult. Okay? Particularly the step multiplying and dividing by sin x. Once you make sure that this step is done nicely, ahead the problem is very easy. Observe कैसे. Okay, so what I am doing further is, I'll say put cos x as t, and if I differentiate with respect to x, derivative cos x is minus sin x, this will be dt by dx. So sin x and dx is going to be minus dt, right? So my question is now getting completely transformed to t, 1 minus t 1 plus t in bracket 1 plus 2t and minus dt. So I am giving minus outside and dt here. So my question is now only this much. We have to integrate t by 1 minus t 1 plus t 1 plus 2t. This is simple now. Partial fraction यहाँ से आगे I think most of you should be able to do it on your own. After those 8 and today's 10 questions के बाद में 11th question, I think यहाँ पे at least first step everybody can do it. So t 1 minus t 1 plus t 1 plus 2t. So what we do here is, this will be a upon 1 minus t plus b upon 1 plus t plus c upon 1 plus 2t. क्रॉस मल्टीप्लाई सिंप्लीफाई करते हैं इसको थोड़ा सा कैसे करेंगे. दिस विल बी a टाइम्स 1 plus t 1 plus 2t मल्टीप्लाई कर दिया. a के साथ डिनोमिनेटर ऑफ b एंड डिनोमिनेटर ऑफ c को मल्टीप्लाई करना है. b के साथ 1 minus t 1 plus 2t and c is multiplied with 1 minus t 1 plus t. Now finding a, b and c का वैल्यू. Think क्या कर सकते हैं. How we can find value of a. To find value of a, I'll put t का value 1. Then this 1 minus 1 will be 0. यहाँ पे 1 minus 1 0 हो जाएगा. So b and c 0 हो गया. a का value ढूंढ सकते हैं, right? How we can find b का value? To find b का value, I'll be putting t का value minus 1. So this place 1 minus 1 0 हो गया. This place 1 minus 1 0 हो गया. तो a and c 0 हो जाएगा. b का value find कर सकते हैं. And to find value of c, what we'll be doing is, I'll be putting t का value minus half. If I put t का value minus half, 2 cancel हो गया, 1 minus 1 0, 2 cancel हो गया, 1 minus 1 0. So we can very easily find value of a, b and c. I want you people to try. I am just writing here the value of a, b and c. हमको क्या मिलने वाला है. You do this, you get a का value 1 by 6, b का value you get minus half and c का value you get as 4 by 3. This three values you get a, b and c का value. ठीक है. You have to try on your own. Substitute value of t equal to 1 minus 1 and minus half. Get this values of a, b and c. ठीक है. After 10 question, 11th question में try it out. Next. So we have to integrate, right? So what will be integrating here? We will be integrating minus. I am keeping outside. So this will be 1 by 6 upon 1 minus t minus half upon 1 plus t plus 4 by 3 upon 1 plus 2t dt, and we want to integrate this, right? This is what we want to integrate here. So minus I am still keeping outside. 1 by 6 integration के बाहर लिख दिया. 1 minus t dt minus half integration of 1 by 1 plus t dt plus 4 by 3 is kept outside, 1 plus 2t dt. Integrate this. How will you integrate? What is integration of 1 by 1 minus t? Log mod 1 minus t, and don't forget coefficient of t here is minus, right? So you have to divide by minus. Don't make mistake वहाँ पे minus से divide करना है -1 से, because coefficient of t here is minus. That's very important step, and make sure that you don't make such mistake. ठीक है? So यहाँ पे -1 से मैंने divide कर दिया, plus not plus minus this half as it is, log mod 1 plus t plus 4 by 3. What will be integration of 1 by 1 plus 2t? Log mod 1 plus 2t, everything divided by 2. Why? Because coefficient of t here is 2 plus c obviously. So we can simplify थोड़ा सा, ये bracket में होगा, यहाँ पे 2 cancel कर दिया. ठीक है? So what we get finally is this minus I am keeping as it is, 1 by 6. यहाँ पे minus कर देते हैं, minus 1 by 6. log mod 1 minus, put t का वैल्यू निकाल लिया था cos x, minus half log mod 1 plus cos x. यहाँ पे बचेगा 2 by 3 log mod 1 plus 2 cos x. Everything inside the bracket plus c. If you want one last step, you can multiply minus inside. ठीक है? So today's 3 question, there are 2-3 steps each question which are very interesting. You have to make sure that you practice more such type of questions, and make sure that you realize this type of question very quickly in the exam, that this is by multiplying, dividing by sin x, or by just taking x square common, you can make it a proper partial fraction question. Okay? So everybody make sure to practice more such question. At present, bye from my side, and see you in the next session. Our next session will be questions on previous year JEE questions from integration chapter. This will be our next session. Be ready for that. Revise all the previous sessions so that in the next session your basic concepts when is thorough, you can do it very easily. So in the time,